Okay, this is the video tutorial for chapter uh, 9 of my textbook, Finite Element Essentials in 3D Experience. And chapter 9 deals with the subject of contact interaction between two parts, basically. So what we have here is a cylindrical part, which is down below this rectangular one, this cube one. So the edge or the side of this block, this box is clamped, and the right side is pushed down by some amount, and it will establish contact with the cylinder, which is clamped at the two ends. And of course, once it establishes contact, stresses will develop, etc. And we like to know what the stress values are, etc. Now, this problem can be done as an assembly made of two parts like that. And obviously we have to solve it as an assembly problem, but there is definitely a symmetry involved. So if you look at the YZ plane happens to be the symmetry plane of this assembly. Therefore, I have two choices. I can solve it without taking symmetry into consideration, or I can actually model half of it. And obviously, when I do that, this circular fictitious surface here and this rectangular fictitious surface that are created are basically on roller support, and these are called planes of symmetry. Okay, there is an initial gap between these two. So when it comes to solving this problem, I can create two separate parts and bring it in as an assembly and position it so that it actually, resembles this geometry that I have here with the gap there. Or I can create these or make these parts as I go along and make sure there is a gap of that size in it. Now, we're going to assume that this is made out of steel. These are the properties of steel. And once it goes to the plastic regime, stress strain, this is true stress versus true strain is given by these values. Okay, so this is the information that I need to plug into to 3D experience for material property at in the plastic range. And by the way, this first one is the definition. This first row is the definition of yield strength. Okay, all right. So let's go ahead and create our assemblies. All right. I'm going to do a remote logging at my account in Europe. So now this will take some time because of the communications, internet communications. So we're going to do that. So I'm already logged on remotely, and now I'm going to start the part design. So this stage will take maybe a minute or so. It's coming up. It's going to ask me whether I want to restore the previous session. The session is saved on your computer somewhere, but it's encrypted and you cannot go ahead and start it from there. However, it will ask you whether you want to start a new session or an old session. Old session being whatever was there before and stored locally on your server, on your own computer. Okay, should be there soon. Right there. Okay, so we are now ready to start our basically uh, simulation module or 3D experience work. Okay, I'm already logged into my account, so let me go ahead and start the application. So we want an assembly design. Okay, it's right there. The first thing that we're going to do, we're going to insert, right click, insert a 3D part right there. So this is going to be my cylinder. It's going to be my cylinder. Right click, properties. I'm going to call this thing cylinder. This is the uh, instance name, and the part is going to be not the part right there. This is going to be this is the instance name, cylinder, and then we say okay. So notice that this changed into cylinder, and now we're going to create the cylinder. So I'm going to double click on, right now I'm in assembly design. If I double click on that, I'm going to end up in part design. Okay, so let's create that cylinder on that vertical plane. I will sketch a circle right there, and the radius of this circle, based on the drawing that I showed you, the radius is 0.5 centimeter, which means the diameter is 1, and 1 centimeter, which is 10 millimeters. So it's going to be 10. Okay, good. Let's fit it in so that we can see what we have done. So view, where's the fit? There we are. Okay, and that's it. So exit, and then we're going to pad it. We're going to pad it in the, that'll be in the X direction. So you go to oh yeah, we are in, this is not the part design, this is generative shape design. So let me switch to part design. Okay, there we are. So there is the pad, and we're going to pad it by a length of 2.5 centimeter, which is 25 millimeter. 25 millimeter. Oops, let me try it again. 25 millimeters. So we say okay. All right. So that what you see here is, oops, what you see here is really this this length, which is 25 millimeter. Okay, good. So just so that it looks like that, let me pat it in the other direction. How about that? So let me go back here, double click on this, flip it. So flip it like that. There we are. Okay. Now we're going to go and insert our second part, which is the block. So insert, right click, insert, another 3D shape, 3D part. And I'm going to change the name of this thing to be the block. So properties, so that is the instance block. And then the part name, no, not the part name, reference is the block. It really doesn't matter whether you rename them in a very systematic way here, because this is a simple problem. But when you do mechanism designs and you want to check the constraints and things like that, it's worth giving these things meaningful name and identical names. Okay, so let's go ahead and make it. So double click on shape on the same plane, namely that what was it, YZ plane. We're going to sketch. Now I'm going to sketch that rectangle on the top. So under sketch, rectangle, center, and I'm going to position it in a second. So this is my block on the top. Let's give these dimensions. So this dimension, according to the drawing, is 6 centimeter, which is 60 millimeters. Okay, and this is 0.5 centimeter, which is 5 millimeters. 5 millimeters. There we are. And we know there is a gap of 0.1 centimeter, which is 1 millimeter, right, between this line and that cylinder. Okay, so let me give it a distance from here to here, 0.5, because the radius is 0.5, 0.51. So dimension between this line and that line, uh, not 0.5, it's 0.5 centimeter and then 0.1 gap, so that's 6 millimeter. There we are. So there is a gap of 0.1 centimeter, which is 1 millimeter there. Okay, so that is our geometry. Exit and then pad it in the other direction, and the length of the pad is 1.5 centimeter, which is 15 millimeters. 15. So what you see here is basically this guy. Okay, so let's move on. Why don't we save everything? Go up here, save everything. Now let's go ahead and apply, create our material, because later on we're going to assume that both of these are made of that material. So we're going to go to now notice that here you don't have access to the material. If you check these things, you don't have access to the material. At least I couldn't find it. So what we can do is we can go to one of these parts, create the material for it, and then use it, for example, to apply it to the other one. So let me go back to that cylindrical part. So I'm going to double click on this. So we are in part design now. Okay, under tools, you're going to add a material, create a material, and I'm going to call it my chapter 9. My chapter 9. And we say OK. It's going to create it here. It's going to be the first one in the list. Right click, simulation, and let's start adding these things. So we have structural, abacus multiphysics, mechanical, elasticity, elastic. So this is going to be 200 GPa, okay? Poisson ratio of 0.3, 0.3, okay? All right, so you can check it, it's there. And then we're going to go to plasticity, metal plasticity, plastic, and check it. So you can input those 7-8 pieces of data here line by line. Oh, we're going to close this. Or you can create, you can write one line of this thing and create, import as or export it as Excel file, open up the Excel file and add it in the Excel file. But it's not worth it, so I'm going to do that right here. So my data, let me see what my data was for a second. Data is right here. And I just noticed that this data that I showed you in that table is not the same thing that I have in the book. So I will be using the stuff that's in the book instead of using this table. So I'm going to add the stuff here. So 2.65 e to the 8, e to the 8, and this is going to be 0. The next line is 2.7 e to the 8, and the plastic strain is 0.005. Next line is 2.69 e to the 8, and the plastic strain is 0.7, 0.007. Line number 4 is 2.67 e to the 8, plastic strain being 0.01. Next line is 3.35 e to the 8. Plastic strain is 0.049. 0.049. Now there's some more lines of the data here. So let me go ahead and get that for you. So you say right click, duplicate row, and I need one more line. Right click, duplicate row. So I have to change these, the last two, and the last two was, this one is 4.8, 4.8 e to the 8, and the plastic strain is not 0.049, not 0.049, because that was a duplicate, 0.196. And finally, the last one is 4.88, 4.88 e to the 6, and the plastic strain is 0.21. Okay. Now, if you look at the table that I gave you here, uh, everything is the same except for the first row. This first row is different from what I entered and what I have in this slide. Okay, so the yield strength is different, but these numbers are exactly the same thing. Okay, so identical. Now, by the way, here you can plot the stuff if you want. Plot this curve. Oh, something is wrong. Something is wrong. I have to, but this is not the right kind of a graph. So let's go and check something. There's definitely something wrong here. So close that. Let's go and check from beginning, unfortunately. So this 2.65 e to the 8, so that's okay. Oh, right here, there it is. This should be 8. This should be 8. Yeah. Okay. So now we're going to go and show me the plot. Yeah. Yeah. Uh, I don't like this particular plot. So what I'm going to do is this. I'm going to say close this, and I'm sorry. I'm going to change this thing to exactly what I gave you in the table, in this table, namely 1 e to the 8. I'm going to use this. Uh, so let's try it. 1 e to the 8. So let me go ahead here. So this first one, we're going to make it 1. Let's look at it. Yeah, I like this thing a lot better. This is a typical uh, kind of stress strain curve that you expect. Yeah, okay, good. So we say okay. So we did actually create a material, but we haven't applied it yet. So let's go ahead and check our material browser. It was this one. Right click, apply. So let me make this thing smaller, apply to this, and apply it to this. And you can always check these. If you go here, for example, check it, you see that it's the same information that I inputted. Okay. And the same thing down here. If you go here, it's going to be identical materials. Okay, good. So let me close this and close that. We don't need it. Okay. So we will now go and create our models. So what I would like to do is to go and create the elements for this particular assembly, but I don't want to do it at the part level. So I go to the top, make sure I am in the assembly design. Look, I'm in assembly design here. I'm not in any part. So I go there and I say, okay, do the structural model creation for me. Now, what it does is that it creates it simultaneously for both of these parts. If you were in one of these parts and you would go to the structural analysis creation, it would just mesh for you that particular part. But this is done in one shot at the assembly. Two of these and two properties. So once again, I suggest that you go to the assembly level and then you create your structural model. Okay, so we get back right there. Okay, so this is fine. The model is created and we're pretty much done here. So we're going to go to scenario. So structural scenario, right? Scenario creation. It's a structural problem. Very good. The first thing that we're going to do is to create our model or basically select our finite element model. Notice that there are two exclamation marks here. So you go to setup, you select your finite element model, and there's going to be one line here because I did it at the assembly level. It lumped everything in there. If you had done it at the part level, probably there would be several of these, and then you have to select them as you see fit. But here, because we did it at the assembly level, there's a single finite element model that we created and we picked it. Notice that this turns now to green. Okay, now we're going to go to restraints. Oh, step. So if you go to the step, procedure, go to procedure. It's a static problem. As soon as you do that, this turns to a check mark. Now, the only thing is, let me see what, this is a nonlinear problem and I want to do it in incremental ways. So let me see what I chose for the initial step. I think I've chosen, I did not change that. So it looks like it's okay. I was thinking that maybe I changed it in the book. I changed this thing to a different increment, but that's okay. We kept it like that. If necessary, we're going to come back and do this. So that's fine. I don't know. Maybe I'll make this thing 0.1. How about that? 0.1. Okay, start with 0.1. Okay. And then we say, oh, here, advanced option, make sure that the nonlinear geometric effect is on because we might have large deformation, and we kind of do here. Okay, good. And now we go to the restraints. As far as this restraint goes, this is a plane of symmetry and this is a plane of symmetry, and you have to do it twice. So you click on plane of symmetry here, you select that. Notice it puts this icon here, and do it again, plane of symmetry, and zoom in, select this circular piece. Notice that it puts the icon there. We know that this end is clamped, so here's a clamp. You select that as clamped. I don't know whether you can do these simultaneously. I think you can do that. Both of them are clamped. Excuse me. And we say okay. Now we want to push this thing down. What is the load here? You look at the load. The load is coming from the fact that we're pulling this down, translating this face or edge or a point. In this case, we're going to do the face by some amount. Apply translation on this face. Now notice that it's in the direction Z. This is perfectly okay with us. And the value of it is, what was the actual value of the translation? So let me see here. Pull down by 5 millimeters. Okay, pull down by 5 millimeters. So we say in minus 5 millimeter in the direction Z. Oops, not there. This is 0 degrees. Sorry. So here, right there, minus 5. Okay, in the Z direction. You can see that. We say okay, and I think we are good. So we're good. So let's save everything before running it. We go to the simulation. Let's do some checking here. Oh, yeah. You know what's going to happen? This is going to go through that because we haven't defined the interaction, contact interactions. That's okay. Let me show you. Let me show you. That's good. Because we have a problem here. I want to show you that if you forget contact, it's going to work, but it's going to go through that. How can I do this? Just bear with me for a second. Every time you have contact, you need to do contact interaction, because otherwise, how does this guy know that there's something that stops it from going? So let's check it out. This is a good actually learning experience. So let's check it. This is not going to be an interesting case because it's just like a cantilever being going like butter, like a knife through that through butter. It's going to go through that cylinder. Okay, so we're almost done. Okay, almost done. All right, let's see. There's all kind of warnings here, which is understandable because this is a nonlinear problem, plasticity and things like that. Don't expect to get something done without any warnings. Hopefully they're not errors. But yep, right there. So close it. I can look at the next one, and the next one, and the next one, and the next one, and the next one. You see, it's going through it. Okay. So this is no good. So we got to do what we got to do is we got to go back to our scenario right there. First of all, let's hide these the stuff. So right-click visualization management. I don't want to see any meshes. So for finite element model, I don't want to see anything. Okay, good. You say we can keep it there or we can close it. It doesn't matter. Now there's interaction here, and we're going to have surface-based contact right there. And then it says, okay, what is your master surface? Master surface, we're going to select this. And for the slave surface, we're going to select the surface of the cylinder. Okay, now we're going to run it, and if it goes through it again, it means that these surfaces don't see each other. That one is obstructing the other one. The first correction there is going to come back and flip this. Okay, so we say all right. Let's go say all right, and now we're going to go to simulation. I'm not going to bother with these first two. I'm going to run it, simulate it, and once again pray that things will work. Okay. Hopefully it won't go through that. If it does, in all likelihood means you have to go and adjust, flip those master and slave surfaces. Okay. Now while this is going, let's check our increments, see where it's going. If you click on that tab, it shows you all the iteration as it's going through it. Of course, it hasn't started yet. Right there, this is the first one, second one, third one, and you can look at the plot of how things are progressing. Okay, and this tab will give you messages, but I'm not going to bother checking that. I'm pretty sure this is going to be okay. Okay, so we're almost there. Not kind of. Yeah, it has to go 100% of that basically deflection, which was it 5 millimeter? Yeah, deflection of 5 millimeter. So right now is at 100% of 5 millimeters. Okay, good. So okay, good. So let's move this thing out of the way. We don't need this anymore. And now you can see what happens. This guy is obstructing it. So if this is the initial step, nothing is contacting. So as you go further, nothing contacting, nothing contacting, nothing, 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 until it gets to somewhere around here. Right now, there's a contact that's established. And of course, yeah, we solved this problem. And you're on your own. Good luck.